Guys, hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In my channel, I deal with the different subjects ranging from mathematics, physics, chemistry, and biology, and other related topics. So today we're going to look at the concept of free energy and equilibria. Of course, this is going to be an introductory part, or rather an introductory part of the concept of free energy, whereby we're going to look at various aspects of the Gibbs free energy and Helmholtz free energy in that specific order. So this is going to assist us find some of the, of course, the criteria that is used, of course, in trying to measure spontaneity, and of course, which are going also to be used in trying to monitor the effect of certain changes on the position of equilibrium, or certain changes whenever a chemical reaction is taking place. Now, we had mentioned from our previous discussion that the concept of enthalpy together with this concept of entropy are the two aspects which are going to be essential in trying to check the spontaneity of a chemical reaction. And therefore, we see that the delta H, which is enthalpy, a negative value of enthalpy, is going to imply spontaneity. So therefore, we're going to whenever we have this specific value for delta H, we're going to, of course, so that is going to imply that the processor is spontaneous. And then we're going to see that the positive value for delta H is going to imply spontaneity in the negative direction, and therefore it's going to be given. So this spontaneity in the reverse, so that's the appropriate one. So it's going to be spontaneity in the reverse direction, as I can just roughly put it. And then we see that the concept of entropy is, so this is for the case of enthalpy. Now the concept of entropy, therefore, we are going to see that the delta S is going to, of course, be the entropy of the universe, that is going to imply the concept of spontaneous change. And of course, there was some criteria that was used in order to show the effect of changes on, of course, this position of what we refer to as equilibrium. And of course, in our previous discussion, we had mentioned the concept of what we refer to as the Lecheterius principle, which of course was used in trying to, the Lecheterius principle together with the equilibrium constant were used to measure this specific effect on certain changes in chemical reaction, as we had mentioned in our previous video. So this Lecheterius, hope my spellings are correct. So this is a Lecheterius principle. So when we were talking about dynamic equilibrium and other aspects, of course, we had mentioned this specific name, and of course, I'm going to just reserve it for another discussion. But the Lecheterius principle and the equilibrium constant were some of the methods that were used to, of course, monitor these specific changes on the position of equilibrium. And therefore, as I've said, these two specific concepts were also used to check the concept of spontaneity of particular reactions. Of course, since some of the chemical reactions are employed in industries and other particular areas of application, for us to ensure that there are optimal conditions which are involved in achieving the desired product, and therefore it's good for us to monitor the various changes which are necessary or can be done in order to ensure that there is optimal, of course, or there is optimal output from that specific process. Therefore, the concept of free energy is going to come into play, whereby we're going to involve the concept of Gibbs free energy, which is another criterion that is going to be used in order to measure this, or to monitor this specific, or describe these specific changes, which are going to be, of course, describing the position or the changes on the position of equilibrium. Therefore, as we said, the Gibbs free energy is going to be denoted, of course, using this delta G, or just a G, therefore implying that the change in Gibbs free energy is going to be given in terms of delta G, given as such. And this is going to be, of course, be more emphasizing on the changes in the system. Now that we have talked about the concept of a system and surrounding, therefore this is going to be creating emphasis more on the concept of a system. Now, in our subsequent video, of course, we're going to develop these ones in terms of algebraic representation of various aspects of Gibbs free energy and the Helmholtz energy, which I had mentioned in the beginning of this particular video. Now then, I hope that we have understood that apart from enthalpy and entropy changes that were used to consider the aspect of spontaneity of various reactions, there's another criteria that we're going to use in order to determine these specific changes, of course, which I've referred to as the Gibbs free energy. And this is going to be very essential, of course, especially in trying to describe the three aspects of enthalpy, entropy, and of course, this specific aspect of spontaneity. So catch us in our next videos. We're going to look at in details the aspect of Gibbs free energy, and that is going to assist us find a way of describing these various changes on the position of equilibrium as I've mentioned. So that is it for now, guys. Bye, God bless you. Catch us in our next video.